I'm Alan Ross. I'm the managing editor of APC Technologies, and we are here at the NETA, the International Electrical Testing Association, their 2023 Power Tech Conference, doing interviews. My guest with me is the Director of Communications for APC Media, Rachel Linke. Rachel, thank you so much for being here.
Absolutely, Alan. Would miss it.
We're just going to have an interesting time with all of these people, and tell me what you like best about these interviews.
The best part about these interviews, I feel like, is that it really brings about a lot of great thought leadership, and I really just love how you make everybody feel so comfortable, Alan. You really try to get people to just be comfortable and in their own skin, and then so much great information comes out of it. So
let's see if we made people in the next interview comfortable. Enjoy. My next guest is Chip Angus. Chip is a dear friend. Chip, thank you, sir, so much for joining me.
Thank you.
Chip and I work together in the reliability world. The reliability of transformers is kind of where I got my feet wet in terms of electrical systems. And it's where you got your feet wet, because you used to be into steel before that, right?
That's right.
Yeah. So Chip, what we're talking about is advanced transformer testing and technologies. And one of the things that you and I have been talking about, all of the great testing and technologies in the world only work if it gives you data that you can do something with. And I know you and I have had some experience with presenting something. I think we called it the reliability assessment. And I'll never forget presenting with you at somewhere in Alabama, and there were a lot of E&I guys from a major paper company from around the globe, actually. And I loved your presentation, your discussion with them about how do you use data. So rather than talk about advanced testing, what I want to talk about is how do you use the testing and the technology we already have to make better data decisions on your transformer fleet. So explain a little bit about that.
Yeah, absolutely. Well, first, to start off, you have to have a robust, good CMMS system. You know, if that data is not funneled into that, oftentimes within the plant, it gets forgotten.
Yeah.
So that's kind of the key to really kicking off a good, robust reliability program.
But are electrical systems in most CMMSs for data management, or have they kind of been left out? They house data, but they don't make decisions on data like they do in the rest of it.
Yeah, I agree, Alan. They've been left out.
Okay.
Historically, I think there's a move to get them in there so they can start generating work orders.
Yeah.
So the upper management and middle management can start understanding the reliability health of those electrical assets.
Yeah.
And you asked me to talk a little bit about our reliability assessment.
Yeah.
Is you have to have a robust program that actually categorizes your assets on a line, on your one line. So your breakers, your relays, your cables, your transformers, they all have to be categorized, whether it's a 1 through 4 system, a mission critical, system critical, or a non-critical system.
Well, talk about that. Mission critical, systems critical. What's the difference between those two?
Well, the mission critical would actually shut down the whole entire mission of a plant.
Okay. It's kind of like big money, right? C-level people get involved.
Yeah, absolutely. So you want to put your dollars into those mission critical assets to keep your plant running. So when you have your shutdowns in September, October, whenever the plants have them, what are you going to focus on first? You want to focus on the mission critical assets, and then move down to your system critical. System critical actually would shut down a system of your plant. So it might be, shipping and receiving, or it might be a smelting line, something along those. So there'll be some damage there, but it's not going to shut down the entire organization.
Could be the sales and marketing office.
It could, or even human resources.
Oh, no, don't say that.
No.
But anyway, the point, I get it. The point being, you can overcome it.
That's right.
But it's going to take time to overcome. Even that is cost damaging. That hurts. And then you run to failure. That's what a lot of people do.
That's right.
So one of the reasons I know that was developed, so you take all of this test data. I'm a neophyte. I got a bunch of transformers.
Sure.
I have identified which are mission critical and which are systems critical. Give me an idea of what I should be using as testing. Not necessarily advanced testing and technologies, but how do I put the right testing into the reliability assessment in order to make great decisions? What's the most important test I should run?
Well, I mean, everyone has heard of the DGA.
Oh, DGA, the most important. Yeah, I know.
Yes,
It
yes.
is the one that everybody says, well, I test my transformers. No, you don't. You do DGA's tests on your
Right, right.
And those, because of monitoring, it's not that there have been that many advances in it. There's been advances in the diagnostic part of it. I mean, you've gone from the triangle, the Duval triangle, to the Duval pentagram, or whatever, the pentagon. But now you have much more robust technology to be able to determine what to do. So DGA, obviously, the most important. What's next?
Yeah. DGA, obviously there's DGA monitoring, but that's a discussion for another time. You have your liquid screen, which is your acid tests, your color, your visuals, your dielectric strength, your furanic compounds. When you combine all those tests together with a really good, robust mechanical inspection, that's going to paint a very clear picture as to what's going on with your transformer. A lot of people don't realize that when labs go to set up their Carl Fisher testing, temperature is important.
Yeah.
So a robust mechanical inspection to assess the gauges. Are they functioning properly? If they're not functioning properly, they're not getting a good temperature reading from the transformer. So labs will often, use a standard. We're going to set it at 20C and run it.
All right.
So you combine all that, and I also recommend that you do your infrared thermography at the time of your sampling.
That's interesting.
So,
Why?
yeah. Well, the reason being is if you get a DGA that comes back and you see high ethane, ethylene, maybe some high hydrogen, maybe even the start of acetylene, that infrared that IR scanning can actually maybe pinpoint where the problem is. Maybe you have a low oil level on a transformer. Maybe you have an overheated bushing. So then it gives you an overall picture of what's going on with that transformer.
Kind of like the testing that you take when you go in for your annual physical. Do it all, take the blood, do all the tests, run everything, and
that's right.
Then he sends you a thing that says you're dying. No, right. But I do want to get to that because one of the things that is critically important, the lead time on transformers as we speak in 2023 right, at the NETA conference. The lead time of transformers is like now going to from 6 months for regular power transformers. It's done from 6 months to as much as 3 years, depending on footprint, and every transformer manufacturer that I know of is sold out. Yeah. I know that Virginia Transformer is just opening a new plant in Chihuahua, Mexico, right?
Right.
State-of-the-art plant for transformers. They sold out the day they opened for 2 years.
Yeah.
So when you're looking at replacements, when you're looking at, hey, I got to have data to decide, talk about the difference between now you're doing life cycle. I got to take it out of service and replace it and it's not because of aging, it's because of condition, right?
That's right.
All things you talk about. Then right below that is I can maintain them. People don't realize they can maintain their transformer. You were one of my heroes of helping people take care of the fleet they've got while they're waiting for new ones to come.
Yeah.
And we can't solve the lead time, but we can say, hey, look, take care of what you've got in order to extend the life of the transformer. How do you extend the life of a transformer through field service?
Yeah, that's a great point. And the lead times on buying new transformers and used transformers has really extended. You used to 10 years ago get a transformer in a matter of a couple weeks. Now it's months and maybe years depending on the KVA size. So that's really driving the market to maintain the equipment that you've got and start implementing these maintenance plans. Some of the things that you can do to maintain them is obviously if you start to see acid rising in a transformer, you can hot oil clean them, reduce those acids so you don't destroy the paper in the transformer. Again, going back to a robust inspection, if you're finding leaks on a transformer, you're better off to fix them rather than either taking in water, going to negative vacuum, pulling in moisture or atmosphere into the transformer. So we're seeing a really big shift in I want to maintain my transformers.
That's good.
Long term. That way I don't put myself in a position to have to go out and find a replacement transformer. Because there's companies out there right now that are suffering because they're trying to catch up on their maintenance and they're years behind.
Yeah. So that's pretty much the industry as a whole. So, we are publishing this in an issue that is called Advanced Transformer Testing and Technologies. What I hear you say is the technology is the data management and the ability to put it into a CMMS. We're not allowed to do commercials here, but I do know that ST Myers has a very robust data management system that is decision dependent. It helps people make wise decisions. Continue to run.
Yes.
Stop.
Yes.
You and I have also had experience where we've told people to stop, they continue to run, and it's a $50 million loss.
Yes.
So that kind of gets the C-level's attention, doesn't it?
Yes, it does.
So I love what you're saying because it's the testing that we do, robust testing that we do, using the technology of data management, and eventually coming to the point where we're using not AI, we're talking about machine learning.
Right.
If I see this often enough, I can start to predict seeing that, engineers love extrapolation and interpolation. We want to interpolate data to say what's happening. Give me 1 point, I can't tell you anything. Give me 2, I got a straight line.
Yep.
Give me 3, I can tell you where things are going.
Right.
Okay, if you're an engineer, don't yell at me because that's not true. We want as many data points as we can, but the testing are the data points anyway. Okay, that's great. Last comments, how are you doing?
Doing fantastic.
Excellent.
Yeah, doing good, busier than ever. There's a lot of people out there that need transformer advice and help.
Yeah.
Yeah.
And that's what the reliability assessment's all about.
That's
it is
right.
advice, counsel, wise decision making. But my friend, thank you so much for joining.
Thank you so much, Alan.